This is Project Cosmos, a multi-agent system to play Kerbal Space Program.
My name is Braulio.
My name is Carson.
My name is Ethan,
My name is Jakob.
and this is our project overview. So our goal for Project Cosmos is to build a multi-agent AI system that can carry out spacecraft missions autonomously based on natural language. And we're going to specifically be using ChatGPT 4.0 here for our project. Our multi-agent approach seeks to challenge current limitations in automating spacecraft operations, which currently still require a lot of human intervention, such as planning and adaptability during missions. And just for reference, an AI agent is a large language model that performs certain actions. And in order to combat these issues, we're going to be creating an AI crew composed of 4 agents: the mission control agent, flight agent, audit agent, and maneuvers agent manager. Our multi-agent framework uses LangChain. We're also going to be using the simulator of Kerbal Space Program and utilizing KRPC as well as MechJeb. And we're going to be using a vector database.
So this is our software architecture diagram. Cosmos uses a multi-agent architecture with specialized AI agents working together to control Kerbal Space Program. The Cosmos orchestrator is the umbrella of our agent system, so it's going to be managing the entire system through the KSP environment bridge that connects the Kerbal Space Program via KRPC. The telemetry collector is on the left, and that provides real-time vessel and space data to all agents, enabling continuous monitoring and decision making, and that's getting that from the KSP environment as well. Our agent communication loop follows a clear sequence. So as you can see in the middle, the green box, that's our agent communication loop. The mission control agent plans missions and proposes next steps based on the telemetry it gets. The flight agent generates and executes KRPC Python code to achieve missions that the mission control agent gives it. And the audit agent monitors progress and provides critiques for improving the code that the flight agent writes. The maneuver agent manages our reusable maneuvers in the maneuver library by basically when the flight agent writes code that's successful and completes a task, the audit agent will declare it as successful. And then we'll actually save that code with a description and a function name in the vector database for later use. We'll do some cosine similarity search and stuff like that to be able to get relevant code that the flight agent can reuse in later missions. This architecture enables autonomous mission execution with continuous learning, real-time adaptation to changing conditions, transforming Cosmos into a sophisticated multi-agent system that can handle complex space missions autonomously.
The KRPC library has drawing and UI classes that we could potentially use to draw modules such as what's on the screen to show some terminal outputs and show what our AI agents are really doing in real time.
Now we get the project progress. So in terms of the product backlog, we have fixed telemetry imports, which is essential for the integration of the spacecraft data. An established workflow between the architecture system allows the agents to actually communicate effectively and coordinate operations. We implemented the starter vector base to store descriptions and scripts. Doing so relies less on the LLM and more on the core memory that we've stored for mission outcomes, and a over reliance on the flight agent and compared to library imports. Doing our current issue is that it's become a technical debt, and we've needed to leverage more towards our imported libraries. For our technical implementation details, we have the Kerbal Space Program, which is just a game, LangChain, which is essentially allows for agent orchestration, predominant in LLM usage, OpenAI API, of course, the KRPC Python, which is a library that allows for telemetry access in the KSP game. And we have the MechJeb 2, which is an autopilot API that's integrated for spacecraft maneuvers, such as launches, orbital transfers, and automated command complexity.
Now moving on to the completed milestones. So we've actually managed to create prototypes for all our agents, and then we've managed to link our agents together to provide us with a functional demo that we'll get into later. And then some issues and strategies. So most of our team members were new to some of the technologies we were using, so we had to spend time on documentation and researching. We had to develop a basic understanding of the simulator we were using, the Kerbal Space Program, and how it works. We also had an unsuccessful baseline mission attempt, so we're just trying to launch the rocket and get it into orbit, but we had some problems with that you can see in our demo video. We improved agent performance by explicitly providing access to KRPC documentation. This reduced errors in command usage. An ongoing challenge is that AI still tries to manually execute some of these complex launch steps instead of leveraging the API, which is actually designed to handle these tasks. And then we're still trying to identify efficient ways to combine the direct agent control with the available automation tools from.
Currently, our flight agent generates raw KRPC code. Instead of using MechJeb2, it will give us access to PIDs, which is able to make better predictions and make better decisions, and also just has more autopilot functionality so that we can write less code and make less mistakes.
And so my individual responsibilities going forward are going to be to adjust the prompt for the mission agent to output a more specific goal that includes relevant telemetry to be passed to the audit agent so that it knows what success looks like and has more of a goal in mind so it knows when that's been met. I'm also going to be researching graph to introduce stateful graph structure control flow to improve mission agent reliability, recoverability, and handoffs between planning, execution, and the audit.
Yeah, so my individual responsibilities are going to be researching the concept of LLM as a judge and maybe looking for any helpful frameworks that can help improve my critic agent. Also experimenting with different prompt engineering strategies that can help the critic agent work better and be more accurate, as well as research into integrating the success telemetry, maybe storing the success telemetry data as templates so the critic agent can compare it with current real-time data.
And my responsibilities is that I'm going to reconfigure the VB to not waste storage from the file scripts, and also just research more into the VB to better understand similarity searches and increase query performance for the Chroma.
Thank you.
Okay, so we went a little bit over.